test and everything the entire time you're pregnant. And this is discovered, okay, either during pregnancy or at the time of birth, okay. They will give the mother something called RhoGAM. A RhoGAM shot. Y'all ever heard of that? Okay. And what that's going to do with the RhoGAM is going to be a way that it doesn't, basically those antibodies, okay, do not go and attack the red. Now, mom has to get that shot. Let's see, she gets it at a point during pregnancy, a point at birth, and then if she goes on to have any other pregnancies, she will continue to get that shot. Because the goal is to basically stop the action of the antibodies so that the antibodies do not go and attack that fetus. Because if those antibodies do pass and go through the placenta, get to the red blood cells of the fetus, what that's going to do, we're going to get agglutination, we're going to get those red blood cells hemolyzing, meaning they're breaking apart. The baby is born with this hemolytic disease of the newborn. I think chances are better now with some of the techniques that they have, but a lot of times it ends up in death of the child, all right? But they also have ways of detecting it, all right? They have ways now when, you know, moms show up for their baby care throughout the pregnancy. I'd be afraid to say how many blood works and tests and everything they do now.
I want to get blood work after this year. They just asked me that I want all these tests.
Yeah.
They asked the date, and then I don't know. I was just like, run them all.
It was 35 years ago that I was pregnant, so you probably had blood drawn twice during the pregnancy, okay? You'd go and they'd do the little hematocrit, the little stick in your finger, but that was it, you know. Now I haven't kept up with that area of medicine. I don't know. You will have to let me know.
I'm going to leave. I wanted to come before so I can show you later. But my baby girl, she's 6, and they keep saying every year I wake up and it's way different now. It's way different. Like,
even from 6 years?
Yeah, my baby's 6, and I just had my blood drawn once when I was pregnant.
Wow. No, I have another ultrasound in 2 weeks.
Okay. Definitely keep me posted and let me know what they test for.
Because they say now they can tell the gender of your baby from your blood, which I was talking about.
Huh?
Yeah, I don't know. I'm going to find out today.
Yeah, you definitely want to let me know about that.
So you can get that RhoGAM shot as many times as you want. I was under the impression
Not as many times as you want.
Yeah, because I thought you could just do it once.
Depending on other pregnancies. All right. So in the first pregnancy, if they determine this is the case, you'll get that shot at time of birth. Okay. Now, when you get pregnant again, I want to say it's at 28 weeks you're given the shot again, and then once that baby's born, you're given it again. So it depends on how many other pregnancies come along behind it. So unless something has changed, but it is something that they have to do with succeeding pregnancies, unless it's changed, which it could, because it sounds like a lot of things have changed now. So I'd have to look into that to know for sure. I know, like, because I had a friend who had this problem, and she had 3 children, and it was given, at 28 weeks in the second, at the end of the second one, at 28 weeks in the third, and at the end of the third. So, but like I said, they could be changed now, because her children were the same age as my son. Yeah. So it's the antibodies that become a problem, and the HDN as a whole can definitely cause death to the babies. All right, but I want to say they've come a long way in addressing this issue. Now, let's get to one of the other formed elements. The white blood cells. They are the least abundant. If you remember, in the test tube that we would centrifuge down, red blood cells on the bottom, white blood cells were the little buffy coat, and then there was this huge amount of plasma at the top of it. So white blood cells are the least abundant. Per microliter, the count should be between 5 and 10,000. But you might hear somebody go, well, they did a white blood cell count and it was like 50,000, blah, blah. Okay, what they're letting you know is something, well, white blood cell count was high, so they were sick with something. It then becomes a guessing game, okay? Unless you do a white blood cell count that looks at every type of white blood cell, okay? I mean, woo! I don't know who'd want that job. But anyway, there's people out there that do that, though. Thank goodness they do it. Now, a lot of what we'll find with the white blood cells, they'll spend a few hours in the bloodstream because their goal is for them to migrate somewhere, all right? And one of the places we want them to migrate to, we want to get them to connective tissue. We want to get some of them to lymph tissue, okay? But a lot of it goes into connective tissue. And if you remember, a lot of the connective tissue, like underlying our skin, along the blood vessels, it's a matrix that's jelly-like, and these cells will get to move through that tissue. And as you know, one of the things about white blood cells, we tend to associate them with keeping us healthy because they're part of the immune system. Their job is to go do something, take care of something foreign in the body. That's how we tend to think of them, all right? Now, white blood cells, they're going to be larger than the red blood cells, and they are complex. They keep their nuclei, so their nucleus stays there. You can see they're filled with lysosomes, for example. Do you remember lysosomes? Because what does the term lyse mean? Break it up, okay? And a lysosome is full of what they call digestive enzymes, all right? Meaning it can break it down just like digestion in our bodies. So as we look at these white blood cells, they're really cool. Have you ever heard of amoebas?
Mm-hmm.
Have you ever seen them under a scope? Okay. Now I'll have to see if I can get some really dirty water and see if I can find us some amoebas to look at. Because they are cool, okay? It looks like you, oh, y'all are too young for this. Okay, you used to have this stuff like slime, silly putty type slime stuff, okay? And if you kind of threw it on the wall, it stuck, you know, and it kind of created this splat on the wall, all right? That's sort of how an amoeba looks, all right, kind of splattered. But the way it moves, okay, is called a pseudopod.
Mm-hmm.
Pseudo meaning false, pod meaning foot. So they basically have the ability to like stretch out their plasma membrane and pull the rest of the cell forward, okay? That is how our white blood cells are going to move. They're huge, they're bulky, they got a lot of stuff in them, okay? And so they kind of want to move in this type of amoeboid movement. Now, The other thing that white blood cells have the ability to do, okay? They can leave the circulation. It's termed diapedesis. They have the ability to leave the circulation, meaning cross that structure of a vessel, of the vessel wall. So they get to leave blood circulation and move into these connective tissues. And that term is diapedesis. You're going to see that probably in your textbook. Now, the other thing that white blood cells can do, they have the ability to release chemicals. They do that to attract other cells, other ways for the body to fight something trying to invade it. And that is because it's a chemical, it's a chemotaxis.
Is the only reason it would leave the circulation is when there is an issue that it needs to be responded to?
No. Basically, once they get formed and they are circulating, they want to move. They want to leave the circulation. Now, you will have them, yes, moving through the blood vessels too, but what they'll do is at some point, like if this is the blood vessel, they will just simply move out of it and go into a tissue and wander around. And if they encounter something, hopefully they can take it in. It's exposed to those digestive enzymes, and bada bing, bada boom, that foreign particle's not there anymore. That's our hope. Okay? So under these white blood cells, if you remember, we have our granulocytes and our agranulocytes. Okay? So for our granulocytes, they have the short lifespan. So what is that going to tell you about an agranulo?
Has a long lifespan.
Has a longer lifespan. So my granulocytes, short lifespans. This includes neutrophils, eosinophils, basophils. Now, have you ever thought about stuff that you could get invaded by?
Like viruses or something?
Viruses, bacteria, parasites, worms, toxins,
Fungal infection.
fungus. There's a bunch of stuff out there that we can get exposed to. Yay! You gotta love it. I won't get into that. All right, so now, if we think about it, all right, a neutrophil is going to be a white blood cell that has the most in number. Okay? Now, neutrophils, they are going to have the highest amount of the white blood cell count unless you get infected with something else that one of these needs to fight. Okay? Neutral. Okay? Because they're going to have that ability to be a first